In question 5, in the expansion of a plus bx to the power 7, where a and b are non-zero constants, the coefficients of x squared, and x to the power 4 are the first, second, and third term respectively of a geometric progression. We have to find the value of a and b. Now, in the first step, we'll try and find the coefficients of x squared, and x to the power 4. We know that the expansion formula for a plus b to the power n is a to the power n plus nc1 a power. So this is n minus 1 and b to the power 1 plus nc2 a to the power n minus 2 and b to the power 2 and so on. Now, as we need the coefficient of x squared and x4, so we can first use, so as the expression is a plus bx to the power 7, to get the coefficient of x, we can use nc1, so that will become 7c1 a to the power 7 minus 1, which is 6, and b to the power 1, so that will become bx to the power 1. 7c1 is 7, so we can write it as 7a to the power 6. The b will remain as it is, and this will be x. For the coefficient of x squared, so we'll be using 7c2, so this will become 7c2 a to the power, so that will become 7 minus 2, that will be 5, and b to the power 2, so that will become bx to the power 2. So 7c2, if we substitute this in the calculator, so 7c2 will be equals to 21. So that will be equals to 21 a to the power 5 b squared x squared. And for the coefficient of x4, we can use 7c4. So that will become 7c4 a to the power. So that will become 7 minus 4, which is 3. And this will be bx to the power 4. So 7c4, if we substitute this in the calculator, 7c4 is 35. So that will be 35 a cube b to the power 4 x to the power 4. Now, as these terms are the first, second, and third terms of a geometric progression, it means that the common ratio, so if we divide the second term by the first term, that will be equals to if we divide the third term by the second term. So first, dividing the second term by the first term, the second term is 21. The coefficient of the second term, which will be 21 a to the power 5 b squared, and the coefficient of x was 7a power 6b, and that will be equal to the third term, which was 35 a to the power 3 b to the power 4, and we'll divide by the second term, which was 21 a to the power 5 b squared. So this will cancel out with 3. 7, this is 7 3 times, 7 5 times. So this will cross multiply. We can write it as 9 over here. So this will be 9. This 6 and this 5 will cancel out. So this will become a, and this b, and this will cancel out, and this will be 9b upon a. A cube and a5 will cancel. So in this case, we'll have, so this will become 5 over here and a squared in the denominator. And this will cancel out, and we'll have b squared in the numerator over here. Now, a and a squared will cancel, b and b squared will cancel over here. So the final expression will be 9 is equals to 5b upon a. As we have to find the value of a upon b, so we'll take a on the left hand side and b also on the left hand side, so that will become a upon b, and this will be equals to 9 will come on the right hand side and divide by 5, so this will be a upon b will be equals to positive 5 upon 9.